Hello everyone, welcome to simplify this nice math problem. Here we have 100 to the power of 7 minus 10,000 to the power of cubed. So we write this algebraic expression into the simplified form. So here the very first step we are going to do is here first you focus on the basis of these two terms, and you very well know about that. We write 100 equals to 10 square, and we write this 10,000 equals to 10 to the power of 4. Okay, so if you open 10 to the power of 4, we will just write it here 10,000, and we write this 100 as 10 square. So after this step here, we need to replace 100 equals 10 square and 10,000 equals 10 to the power of 4. So after replacing these two values to the above equation, so that our above algebraic expression is written as so this will becomes 10 square and its exponent is 7 minus, we write this as 10 to the power of 4 and its exponent is 3. So further we need here exponent law, and you know that if you have a to the power of m to the power of n, it is equals to a to the power of m times of n. Here we apply this nice exponent laws on both of these terms, so that when we apply this exponent law in the first term, it will be written as 2 sevens are 14 minus, here we write this term as 4 times of 3 becomes here 12. 4 3s are 12. Okay, so now here first we write our given expression into the simplified form. So the simplified form is this one, 10 to the power 14 minus 10 to the power 12. And now after this step, here we again focus on the exponent of this term, and we have this is 14, and we write it as 10 to the power of 12 plus 2. Here we break this 14 as 12 plus 2 because of, if you see here, we have 10 to the power of 12. So now in order to make this exponent same, we write this 14 as 12 plus 2. Okay, so that's the reason we break 14 as 12 plus 2. So we write it as 10 to the power of 12. So here after this step, here we need to focus on the first term, and here we apply this exponent law. You know that if you have a to the power of m plus n equals to a to the power of m multiplied by a to the power of n, here we need this nice exponent law in the first term. Okay, so after this step we see here, here we need to break this exponent, and we write these two terms separately on this base 10, and we write it as 10 to the power of 12 multiplied by 10 to the power of 2 minus this is 10 to the power of 12. Okay, so further you see here we have 10 to the power of 12 be the common term, so that now we take common 10 to the power of 12, and the remaining terms are here. When you take common 10 to the power of 12, we get 10 squared minus, when you take common 10 to the power of 12 here, then you get only 1. Okay, so after this step, here in the start of the problem, we will write here 10 square equals to 100. So now we replace this 10 square equals to 100, and it will be written as 10 to the power of 12 into 100 minus 1. And we know that 100 minus 1 equals to 99. Okay, so it means that now we multiply 99 to 10 to the power of 12, so that we write it as 99 multiplied by 10 to the power of 12. So here you see that this is 10 to the power of 12, and this will be not in scientific notation. So now here first we need to convert this into the scientific notation. So if you focus on this term, we have the decimal on here. So now we move this decimal to one digit before this 9. So we write it as 9.9 multiplied by 10 raised to power 1. Because we move a 9 to one digit here, so that we write 10 to the power 1. and this is our 10 to the power of 12. So here you see that basis on these two terms are same, so we write it as 9.9 multiplied by 10 raised to power 13. So here you have, this is 1 plus 12 becomes here 13. Okay, so after that you see here the exponent of this 10 is positive. So when you can remove this or when you write this scientific notation into the ordinary notation, then we move this decimal 13 digits to the right side. Okay, so here in order to move 13 digits to the left, sorry, we move our decimal in this direction in 13 digits. So we write it as 9. So this is one digit and you have the remaining digits, then you can just put up the zeros here, and then we write it as uh, uh, 9. So this is one digit and remaining 12 digits, so we write 12 zeros. So you get here 1 2 3 4 5 6 7 8 9 10 11 and 12. Okay, so this is the nice simplified form of the given algebraic expression. So this is the ordinary notation. Okay, this is the ordinary notation and this is the scientific notation. We can write scientific notation as Sn and we write the ordinary notation as On. Okay, so these are the two simplified form of the given algebraic expressions. And I hope so you like this video. This is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.